These are some simple time value of money problems to get folks started with. This first one, Fred borrowed $10,000 from his uncle, agreed to repay him in annual installments of $2,637,000.97 each year for 5 years. What's the annual interest rate on that loan? All right. It's a 5-year loan, so there'll be 5 total payments. And each of the payments will be $2,637.97. He agreed to completely repay him, so at the end of the 5-year period, he won't owe any more money, so the future value will be 0. And the present value, we're going to use negative $10,000 as the present value. Now, when you're looking at PV, FV, and payment, one of them has to be positive, one of them has to be negative, and the third one could be positive, negative, or 0. You have to figure that out, but how it solves the problem is it has to be able to add together positive and negative numbers. Here's a pretty simple one. If the FV is 0, which means there aren't any payments beyond the 5-year, really doesn't matter which one you make positive and which one you make negative as long as these are two different signs. To solve for the rate, the Excel function equals rate, and you can see all the items you got to enter in the order you got to put them in. The easiest thing to do, put the cursor on this little FX button up here and pull up the help box. Number of periods, cell C4, payment, cell C8, present value, cell C6, future value, cell C7. You really don't need to put in the type at this stage, and I'm using cell references for reasons, because all these problems that'll solve for rate, if I'm using cell references, then I can just copy this whole mess down and use it again. And I'll show you how that works when I do the next iteration of this problem. Hit the OK button, and that's the annual interest rate on this loan because it's making annual payments. Now, the second version of this, Fred borrowed $10,000 from his uncle, paid him $1899 in annual installments plus a lump sum at the end of the 5 years. It's the same problem, but the payments are a little different. So all I have to do now, if Fred made 5 payments of $1899 and then a lump sum payment of $5,000 at the end, again, that's why I use cell references. Since I have this set up and always highlight what I'm solving for, then the only thing that changed here is Fred's payments went down per year because he's paying off $5,000 on the last, at the end of the 5th year. Alright, the next problem is $10,000 and now he's making monthly payments. Well, all the same stuff, except that instead of being 5 yearly payments, it's 12 monthly payments a year for 5 years. Still got $10,000. This one, there's no lump sum payment at the end, but there is $212.47 in payments. Now what I get when I calculate this is now that the rate is the monthly interest rate. Monthly payments, monthly number of periods, you're going to solve for a monthly interest rate. To convert a monthly interest rate to an annual interest rate, there are 12 months in a year, multiply by 12, and only slightly rounding error is the only difference. Notice that this is a 10% loan, 10% annual loan, this is a 10% annual loan, this is a 10% annual loan. If we go out and look at version 4 of this, $10,000, he's going to pay him back $147.90 and then a $5,000 lump sum at the end. Well, copy all this down. Copy this one down because it's got the lump sum in it. He's going to be making monthly payments of $147.90 for 5 years, so that'd be 60 total payments. Convert them monthly to an annual. Alright, so these first 4 problems here are just 4 different ways to set up a payment structure. Alright, which gives you some idea of the flexibility people have in making payments. By the way, I started out making the present value negative and the payment positive. I made that positive and made that negative, it's still going to give me 10%. As long as these are 2 different signs, we're good to go. Now when you added this lump sum payment, this is a situation where it does matter, okay? If I put the wrong sign on the future value, hopefully I'll get an error message, but not always. See, and in this instance, I actually get an answer. It's the wrong answer. So, word of caution, you need to be careful on the signs with any of the dollar amount, the dollar denominated entries. And those are PV, FV, and payment.